Hey everyone, so today we will discuss a problem called magic square on HackerRank, forming a magic square. I'll add a link to this problem in the video description. For this problem to be solved, we need to understand what a magic square is. For that, you can come to this problem statement and go to this link here. It's a link and understand it in depth, or you can also come on to this page and understand about how many 3 by 3 magic squares are there and all those things, because this is going to help you understand and solve this problem. I'll be giving you a hint or a basic idea of why we are using this resource further in the video as well. But for now, if you want to visit this link, feel free to visit and pause the video. Okay, so what we basically need to find is, given S, that is an input, a 2D matrix, convert it into a magic square at minimal cost and print this cost on a new line. Okay, so this is our S input matrix, and we need to find out how many values do we need to change in terms of for it to be a magic square. So the number of values that we are changing, we need to find the sum of that, but in absolution. So absolute values. So what we are basically doing here is, we for example, this took 3 replacement at a cost of, so for to convert this matrix into this matrix, which is a magic square, we had to change these many elements. Now, I'm not going to read it in depth and try to make you understand the problem. This video is more about understanding the approach or the solution of this video, of this problem. So feel free to read the problem description on your own pace. And so this took 3 replacement at a cost of 7. So our minimal value would be, or the minimum cost would be 7, that we are going to print out in the end as per the problem statement requirement. Again, we have more sample inputs, so feel free to go through them as well. Now, in order to solve this problem, you need to understand what a magic square is. So, given a n by n matrix of or a magic square, the first property of magic square is you can add any row or column in the magic square, and the sum would always be a constant number of all the sides of all the diagonals, everything. It will always be a single constant. So here, if we take a magic square of total sum 15, which would be formed by within the range of 1 to 9. So within the range of 1 to 9, every time that we try to make a magic square, the sum total would come as 15. Why? Because all the numbers that we are adding from 1 to 9 would be equal to as 45. And now, since we have to have 3 of the rows here, if we divide that, then 45 divided by 3 would be 15. So this is like observation, first one. Second one is that always 5 in we have, like, we will have 8 magic squares. The number of patterns or the number of combinations that we can form a magic square is totally 8, with 1 to 9, where the sum would be 15 of any row or any column. So for that, in order to understand how that is being done or what is the whole approach, feel free to read this whole article. I'll add a link again. There's a video as well. And here you will see that there are 8 possibilities or 8 patterns. All we need to do is, we need to save this. We need to save this in an array like this. So in this array, this is denoting one magic square. Okay, so this is a 3D vector or a 3D array basically. So here we have 8, 3, 3, which means 8 is the total number of magic squares, 3 is the total number of rows and columns in every magic square. Now, This is the basic understanding of the problem. Now we'll move ahead and try to understand the patterns. So in any magic square, um, just a moment. Yep. So in any magic square, we try to find patterns, and based on that, we try to solve this problem. So in any magic square, there will always be only two patterns for us to understand. First one is this cross pattern, and second one is this plus pattern. And in all that eight patterns or combinations, if you observe, five in the center is always at the same place. Five, 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 five. So everywhere, five is in the center. Now, the next thing is that in this diagonal pattern, 2, 4, 6, and 8 will always be on the diagonals. So they can jumble up. For example, 4, 8, 2, 6. That's not a problem. That will happen. But always these values 2, 4, 6, and 8 will always be on the diagonals. And 1, 3, 7, and 9 on the plus symbol formation. So you can imagine as 1, 5, 3, 7, 9, or they can jumble up. Like in this pattern, they can mix up. But there are limited ways to sum to 15 with numbers from 1 to 9. So these are the patterns, or these are the limited ways. There are only 8 ways for us to do so. That is why we are taking a vector or an array of size 8, which has magic squares of size 3 by 3. So if you are having a hard time understanding this, you can imagine it as 8 by 8. We have total 8 magic squares. So we are entering into this array or the bigger square, which has 3 by 3 3 by 3 matrices, right? So you can imagine it that way as well if you are having a hard time understanding it. And then the next thing that we need to do is, this is where our a lot of work has happened already. Now we need to find the minimum cost. Minimum cost as in what exactly minimum cost is here. So minimum cost, as explained earlier in the problem statement as well, is if this is a like this is a perfect magic square in our array, right? But our input is not a perfect magic square. There will be some numbers which are repeating, some numbers which are not on the correct place, or there can be multiple things. So what we need to do is, we will have to replace that number with the number which will make it a magic square, which will make our input a magic square, right? So with that change, we will keep adding that and subtracting the difference of the change of the number that is being changed. We will keep on subtracting that and adding all that differences in the end. So that will be our minimal cost. And in that way, we need to return the cost which is the minimum to convert that input into a magic square. Here, this input or this matrix is going to be compared with all these matrices, which are inside this magic square array. And every comparison will have a minimum cost, will have a cost which is, or will, let's say, it has some cost. Okay, but we will update our minimum cost every time the comparison happens, and we will save that. If the minimum cost is more lesser than the previous comparison, then we'll update our minimum cost. Now the next concept, we are updating minimum cost as int max. Why are we doing that? Int max is the maximum value any integer or constant can have in C++. So why are we doing that? We are doing it for the guarantee. So for example, if you want to go buy somewhere something, and you want to ensure that the minimum, you can buy it in the minimum cost, but the amount that you have, the total amount that you have, for example, let's say you have 1 lakh rupees, but you want to buy it in the minimal price. So any price within 15 lakh rupees is going to always, or 1 lakh rupees is always going to be minimal, right? I hope that's making sense. So we are keeping int max so that whatever minimum cost in the first iteration, basically the focus is first iteration. Whatever minimum cost comes up, our variable min cost would get updated, because any value, whatever value is there, is never going to be larger than int max. So that is why we are taking int max here, to increase our chances of getting a appropriate result. So with that, we move on and we compare the values, and then count the differences and add up the differences and return the absolute value in the end. So that is what is all we need to do here. So for that, I'm taking a array for the whole array, so that's why I'm keeping the boundary condition as k less than 8, and then we are keeping a current cost value inside the loops, so that our current cost we can keep a track of. And then we have two more loops. Um, so here, like, you can also go with an approach where you do not want to use two loops. Rather than that, you want to use one loop. That is also okay, that is up to you. But here, for the ease of understanding, I am using two loops. So for after coming into this array with this boundary condition, so you can visualize it this way, that with this loop you came into this array. Now with this loop you're coming here somewhere, and then with this loop you are selecting one of the values, right? So for that, you are inside of this matrix, and now you want to compare. Every time the comparison happens, you want to update the minimum cost variable, and for that we are using a function called min, and we are comparing these two values and ultimately saving the minimum value in our min cost variable and returning that. So current cost is equals to current cost plus absolute value of s of ij, that is our input, minus magic squares of k of I of j. Okay. So every time current cost would be getting added to this value. Okay, and then we are updating current cost in the end. That's it. I hope this makes sense. And that's it. That's what I would like to tell you guys, that just understand this problem well, and in future this is also going to help you grab approach to solving these kind of problems, matrix based problems. This is majorly a maths or matrix based problem, and the time complexity would be O of 1 constant time, because we have constants here and we know how many times the loop would run. So that is the solution and time complexity of this problem as well. Hope this helps. Do let me know if you have any doubts, comments, or feedbacks. Thank you for watching. Bye bye.